Okay, so I'll say that again because I just hit record, but your test is 30 questions and we'll go ahead and get started. I don't want to wait too long. Okay, nobody has any questions or problems? Everybody good? Okay. Okay, so the study guide, I'm not really thrilled with. I don't make the study guide. Because they have the questions separated by chapter, and I don't really like that. I wish they were all mixed up because your test is going to kind of be all mixed up. So I'm really kind of sorry about that. I don't know why they did that. That's lazy, but just kind of, regardless, you guys can study the questions the way they are. But here we go. Okay, so, study guide, Case, before you get too comfy. Okay, so while Case is back there, let me go ahead and talk about the other bonus real quick also. So I laid some chapter 6 packets back there just in case you guys have lost yours because we covered that many moons ago. But in chapter 6, in the chapter 6 packet, right before additional problems, you had these 3 differences in the probability distributions between discrete random variables and continuous random variables. This is going to be a bonus, a big bonus. This is your only bonus that's not a riddle. So if you lost your chapter 6, or if you just don't want a chapter 6 and you want to screenshot this, you could get your little phones out and screenshot this, or you might already have it. But these will be the differences, the 3 differences. You don't have to write these word for word. You can just tell me that a discrete random variable has countable, continuous random variables and intervals. You can tell me that discrete random variable has probabilities with points. Continuous random variable has intervals. And then again, it kind of repeats itself down here with this too, but this would be the bonus for the test, the only statistics bonus for the test. Okay, so again, if you need that, they're back there. Okay, so let's jump right in then. Here we go. So number 1, it says a continuous random variable is a random variable that what? Well, you got 4 options here. Anytime you see continuous random variable, you want the answer that says intervals, right? That's the whole point of a continuous random variable. Discrete or countable, continuous or intervals. So that's our answer there. Okay. All right. Still talking about continuous random variables. So the probability that X assumes a value in an interval is what? So what are the range of probability values really for continuous or discrete? Your probabilities can be between what? Anybody remember? 0 to 1. Good. 0 to 1. So you want to make sure and remember that. The key there is the probability can be between 0 and 1. Okay. For number 3, all right, this is the same question. They just reworded it. So for a continuous random variable, the area under the probability distribution curve, that's the same thing as the probability, between 2 points is always between 0 and 1. It's just another way to say it, okay? All right, so now let's think about this curve, the whole curve, right? The total area under the entire curve is going to be equal to what? 1, right? Good. Okay, now number 6 is that trick question because we're talking about continuous random variable. Remember, the key word for continuous is it has to be an interval. So this is the trick. The probability that a continuous random variable X assumes a single value, remember, CRVs use intervals. What's the probability it's going to have a single value? 0. Remember, that was even on Wiley. That's a trick question. Good. Okay, and then we're back to talking about our normal distribution. Okay, which of the following is not a characteristic of this? So we know the total area under the curve is 1. We know it's symmetric about the mean. We know the 2 tails go out indefinitely, but the value of the mean is not 1. For standard normal, the value of the mean is 0. For normal, we don't know what it is. So it's B, okay? All right, so if this is our curve again, here's our mean, we're in the middle. We said the area under the whole thing is 1. So the total area under a normal distribution curve to the left of the mean would be what? It would be a half. It would be 0.5. So this could also be what's the area to the right of the mean. It's also 0.5, right? They're 0.5 either way. Good. Okay, so now we're going to get a little more specific. So now we're talking about standard normal. Okay, so for standard normal, those are your Z's. What's your mean and what's your standard deviation going to be? 0 and 1. Good. You know it's not going to be B and you know it's not going to be D, but just watch yourself. Don't get confused and put A, right? Your mean is 0, your standard deviation is 1. You don't want to get those mixed up. Okay, so here we go again. Let's say we got a Z value. All right, here's our mean, okay? For a normal distribution, the Z value for an X value, I know that sounds confusing, that is to the left of the mean, okay? So if we're talking about Z, then that means the mean is 0. What are all these values on the number line to the left? They're going to be negative, okay? And then all the values on the number line to the right are going to be positive, okay? All right, now for 11, 12, 13, 14, you can use your Z table if you want to, but I think we're all pretty calculator savvy people in here, right? We kind of agreed that was really the easiest way to do that. So, okay, for every single one of these, they ask for the area. If they want the area, that is going to be normal CDF, right? Anytime they ask for the area, that is normal CDF, okay? So remember, for normal CDF, you're going to need a lower bound, an upper bound, a mean, and a standard deviation. Now for, let's see, 11 through 14, they all talk about Z's. That means my mean and my standard deviation are 0 and 1. So all you have to come up with is the lower bound and the upper bound for every single one. So let's look at number 11. It wants an area, so I'm normal CDF. It gives me 0 and it gives me 1.92. So my lower bound is 0. My upper bound is 1.92. I'm going to put in 0 and 1. And you should come up with B as your answer. Okay, so let's just do one of those just real quick to make sure you remember how to do that. So we're going to go normal CDF. Okay, let's see. And then my lower bound, here's my 0. My upper bound, 1.92. My mean is 0. My standard deviation is 1. And there it is. Okay, everybody remember how to do that? Okay, all right. So let's go back here. Number 12, same thing. Now we want a lower bound and an upper bound. Look what they did though. They put them in the wrong order. So if you just grab them the way that they are and put 0 as your lower bound and negative 2.43 for your upper bound, I honestly don't know what would happen, but I don't think it would be good. So you got to remember your lower bound's the smallest, your upper bound's the biggest. So your lower bound's going to be negative 2.43. Your upper bound is 0. You put in your 0 and 1, and I came up with 0.4925. Okay. All right, everybody okay on 11 and 12? All right, now 13 and 14 only have one number. So you're going to have to come up with one of the bounds on your own. That means one of them is going to either be negative infinity or positive infinity. So this wants us to be to the right. So if we want to go to the right, okay, what's my lower bound going to be? The given, right? The negative 0.78. And my upper bound is going to be positive infinity. And remember, that's the 1E99. Is everybody comfortable putting that in their calculator? Anybody need to see that, or are you guys okay with it? Good, okay. All right, let's see, I got 0.7823, okay. Number 14 wants the area to the left. So remember, if I'm going to the left, then my lower bound is going to be negative infinity. The only thing that changes for positive and negative infinity is the 1. It's either a positive 1 or a negative 1. It's still E99. And then my upper bound is going to be negative 1.53. Okay. And let's see, I came up with 0.0630. Okay. Everybody good putting that in their calculator? You sure you're good? Okay. All right. Let's see, I think there might be one more on the other page. Yeah. Okay, so 15, last one of these. Okay. So again, this is asking for the area. Okay, I'm trying to really stress that because there'll be a confusing part coming up. So area means normal CDF. That's what you want in your calculator. Okay, so here we go. I see the letter Z, so I know I'm using 0 and 1. And I see a small number and I see a big number. So I've got my lower bound, my upper bound, 0 and 1. It's going to come up to be 0.2413. Okay, now let's look at the next two. Okay, the next two say let X, now we're talking about X, have a normal distribution with a mean of 40. So now I have a new mean, there's my mu, and a standard deviation of 6, that's my sigma. Okay, this wants the Z value and it gives you X. Okay, 16 and 17 are both the same. If it wants a Z value, you're going to use the little equation X minus mu over sigma. That's what you're going to use for those two. Okay. Okay, so if you have your little sheet out, your little key formula sheet, here it is, right under chapter 6, it's this first little equation. If you just kind of want to highlight that or circle that. So given an X and it wants a Z, that's the formula for that. Okay, given an X and it wants a Z. Okay, so here we go. My X is 52 minus mu, which is 40, divided by 6. Okay, now this is the one you have to be careful with in your calculator, because if you put it in just like this, order of operations is going to take over and give you the wrong answer. And that wrong answer will be a choice. It will absolutely be a choice. So make sure you put that top in parentheses, or make sure you hit enter first before you divide it by 6. That's really, really important. So let's see, 16, I got 2 for that. Okay, make sure you get 2 for that. So 52, is that right? That's, oh, thank you. Okay, sometimes I panic. Okay, so there we go. All right, let's look at 17, same thing. So I'm gonna have 53. Now my mean is 50 divided by standard deviation of 4. Okay, so again, handle that numerator by itself. And what did I come up with? 0.75 is what I came up with for that. Okay, make sure you don't do anything wonky with it. Okay, all right, 18 and 19. They both ask you for the probability. Okay, again, that's normal CDF. So probability or area, same thing, right? Area under the curve is the probability. So whichever one they ask you for is still normal CDF, whether it's the probability or the area, either one, you're using normal CDF, lower bound, upper bound, mean, standard deviation, okay? So the GMAT scores of all examinees who took the test this year are normally distributed with a mean, okay, there's my mu, of 420 and a standard deviation, there's my sigma, of 40. The probability that the score of a randomly selected examinee is between 390 and 450. There's your lower bound, there's your upper bound. Okay, what did I come up with? 0.5468. Okay, so normal CDF if it wants the area or a probability. Okay, number 19. Am I going too fast? Are you guys okay? I just don't want to run out of time. Okay. Number 19. The heights of all female college basketball players are normally distributed with a mean of 68 inches and a standard deviation of 2. Okay. The probability, so normal CDF, that the height of a randomly selected female college basketball player is more than 66.5 inches. Okay, you got to be careful here. We need a lower bound and we need an upper bound. So if I want to be more than 66.5, then my lower bound is 66.5 and my upper bound is infinity. Now remember, we talked about the fact that we know nobody has a height of infinity. We know that doesn't make sense logically, but to use these formulas, those are your bounds. So you have to put that in, okay, as your upper bound. And then when you do that, you should get 70.7734. Okay. Okay. Moves us to 20 and 21. So far we know what to do if it asks for the area. We know what to do if it asks for Z. We know what to do if it asks for the probability. Okay, but let's read this one. This says if the area under the standard normal curve from 0 to Z is this, and Z is positive, then Z is, now we have to be careful here because this is asking for Z. Well, 16 and 17 asked for Z, but what did they give us? X. This is the formula we use when given X, okay? Down here, they also want Z, but they don't give us X. They don't even mention X. So this is going to be inverse norm. This is used when given the area, okay? When given the area. So inverse norm, find Z given the area. This little formula, find Z given X. See the difference there? Okay. All right. Now remember, with inverse norm, you want the area to the left. So it's a little different. Okay, so here we go. If the area under the standard normal curve from 0 to Z, okay, here's 0, Z is positive. So Z's over here, and this is 0.4826. What is Z? Okay, so I don't know if you remember this, but we made ourselves a little chart here, which I don't have out, where we said, okay, when we're using inverse norm, okay, this is what we're going to do. We're going to say, okay, for our area, inverse norm, your area has to be to the left. Okay, so this might be something that you want to write on your little key formula sheet. If they give you the area to the left, left tail or area to the left, you're good to go. You're going to put it in. If they give you the area to the right or in the right tail, you're going to do 1 minus that area. Okay. If they give you an area from 0 to Z, and Z is positive, you're going to do 0.5 plus the area. If Z is negative, you're going to do 0.5 minus the area. Okay. That's going to be the situation for your inverse norm. So you want Z and you're given an area. This is how you need to treat your area. If it's the area to the left, you're good to go. Area to the right, 1 minus. If they give you a little chunk from 0 to Z and Z is positive, do 0.5 plus the area. 0 to Z and Z is negative, 0.5 minus the area. Okay, and then that'll take care of all your issues that you come up with. Okay. All right, so here Z is positive and it's a little chunk. So what am I supposed to do with this 0.4826? I'm going to do 0.5 plus, right? I'm going to do 0.5 plus because it gave me a little chunk from 0 to z, right? And told me z was positive. So I'm going to do 0.5 plus. So the area I'm going to use is 0.9826. That's the area I'm going to use inside inverse norm. Okay. All right, so let's try that in our calculator. Okay, so we're going to do, let's see, second bars. We're going to go, there's inverse norm. Our area is now 0.9826. I put in my mean of 0, my standard deviation of 1, and my answer should be 2.11. And that's my A. Okay. Sound good? Okay, let's try the next one. The next one tells me the area under the curve from 0 to z. Okay, remember, if we have 0 to z, we're going to have to figure out, is z positive or negative? Here, z is negative. So the area I'm going to use is 0.5 minus what they gave me. That's going to be 0.0045. That's going to be my area that I put in there. And when I do that, I got negative 2.61. Okay, make sure you can put that in there. Your inverse norm, that in there, comma 0, comma 1. Does that make sense for those? Okay. All right, so if it's positive, it's 0.5 plus. If z is negative, it's going to be 0.5 minus. Okay, because we're trying to find that z value to the left there. Okay. Is everybody okay with that? That makes sense? So this is what I'm putting in to my inverse norm, comma 0, comma 1. Did you get that, Landon? Okay, everybody got it? Okay, good. All right. Okay, so then we just have 3 little questions to kind of finish up chapter 6. So first is the relative frequency. Okay, so to find the relative frequency for a class, you take the relative frequency, or you take the frequency of the class and divide it by the total. Look at B. B is on there just because they hate children. Okay, read B. It's the same answer and they added a word in front. Don't pick B, right? How can you find the relative frequency by taking the relative frequency and doing something to it? You don't know it yet. So how can it be part of the problem, right? You got to take the frequency and divide by the total frequency. So be really careful with that one. Okay, 23. Normal distribution. The spread of the curve decreases and its height increases as what happens? Well, the spread of the curve is the width, okay? And its height increases when the standard deviation decreases. The standard deviation and the width are the same thing, So as your width decreases and your height increases, remember the belt, that's what's happening. But the standard deviation is the width of the curve. That's that number line that you see there. Okay, 24. So for a standard normal distribution, the z value gives the distance between the mean and what? And a point in terms of what? Do we remember the whole thing revolves around what? Standard deviation, right? When in doubt, pick standard deviation. The whole thing with this is standard deviation. Okay, so that kind of takes care of chapter 6. That was kind of a whirlwind. Here we go. Chapter 7, we'll slow down a little bit. Okay. Chapter 7 is an oldie but goodie. This is reaching way back. I don't know why they're still doing it. Okay. A population contains 10 members. the total number of samples of size 4 that can be drawn without replacement from this population is what? This is a combination problem. Remember that? Remember NCR from way, way back? Okay. Remember that N is your biggest number. So you're going to have to read them, but it's going to be 10C4. Let's see if we can remember where to find that. So if you're on watching the video, what we're doing is we went to math, and then we're going to scooch over to PRB. That's your probability. And then sure enough, there's your NCR. Unfortunately, I forgot to type in 10 first. So I got to go back. So 10, then I go math, scooch, NCR, and then I type in 4. And my answer is 210. Okay. So that's an old one. You got to go way back to find him. So he's under math. And then you scooch over till you get to PRB, and then you'll find it. Okay. And put your bigger number first. All right, 26. I don't know if you remember sampling error. So a sampling error, that's the one that you really can't help, right? That's just the difference between the sample statistic and the population parameter. They're going to be a little different, and that's just your sampling error, okay? A lot of students want it to be this error that occurs with collection and distribution. Remember where you accidentally write down the wrong thing? That's a non-sampling error. That's just human error. So don't pick that one, okay? All right, let's see. 27, as your sample size gets bigger, the standard deviation does what? Anybody remember? It gets smaller, okay? The bigger the sample size, the smaller the standard deviation. Remember, standard deviation is kind of the difference between the number and the mean, right? Okay, so let's see. 28, and there's another one that's really similar. We'll just stick with that. Okay, 28. So, 28 and 29, they're almost exactly the same. 28, for a continuous random variable X, the population mean and the population standard deviation are these two respectively. So what does that mean? What's your population mean going to be? Which number? 80, right? It just means the first one. And then your standard deviation is going to be the second one. Respectively just means whatever they mentioned first is the first number, whatever they mentioned second is the second number. Okay, the mean of the sampling distribution of the sample mean for a sample of 25 elements taken from this population is what? This sounds like something a lawyer wrote, right? You can't even figure out what they're talking about. They want the mean of the sampling distribution. That's what they want. So if the mean of the population is 80, what's the mean of the sampling distribution? You guys remember that? They're the same, right? They're exactly the same. And here it is. If you want to see it on your key formula sheet, under sampling distribution, the mean of the sampling distribution, that's mu x bar, is mu, which is the mean of the population. So it's 80. It's just 80. They're the same. Okay, let's look at 29. Now remember, we're going to ignore this little disclaimer. We don't have to worry about him. We're just going to ignore that, right? Because that's going to be there for everything. It's basically the same question, just with the values changed. But this doesn't want the mean of the sampling distribution. This wants the standard deviation of the sampling distribution. And it gives you a sample size. Okay, so if you recall, okay, here's your key formula sheet again. The mean is the same. Your standard deviation is not. Remember, that's the whole difference in chapter 7. Your standard deviation, you have to take the population standard deviation divided by the square root of the sample. So what it wants is this, which is sigma divided by the square root of n. Okay, the mean is the same. The standard deviation you have to fix. So I'm going to have 20 divided by the square root of 16. And that should give me 5. Okay, so the mean of the sampling distribution is the same. The standard deviation of the sampling distribution is different. Okay, let's talk about the CLT here. For your CLT, your sample size has to be a certain number for you to use this. Anybody remember the magic number? 30. Is it going to be less than 30 or 30 and bigger? 30 and bigger. That's your secret. CLT has to be 30 or bigger, your sample size. Okay. Okay, let's see here. All right, so a population has a mean of 100. That's mu. It has a standard deviation of 32. There's your sigma. Assuming we can apply the CLT, it wants the probability. What do we use if it wants the probability? Anybody remember? Normal CDF, right? Anytime it asks for probability, you're doing normal CDF. Okay. That the sample mean of a sample of 64 elements selected from this population will be between 90 and 95. Okay, so my lower bound is 90. My upper bound is 95. But now I'm talking about sampling distributions. What's my mean going to be? 100, right? The mean does not change. What changes? We just talked about it. Standard deviation. So if it gives you a sample size, then you're going to take 32 divided by the sample size. That's going to give you your sigma x bar, which is 4. That's what you're going to plug in, okay? So the only difference in chapter 6 and chapter 7 is chapter 7 gives you an n. If you see an n, you need to take the square root of it and divide your standard deviation by it and plug it into normal CDF. And I came up with 0.0994. Okay. Is everybody okay with that? Okay, let's look at the next one. This next one also wants a probability, so normal CDF. Okay, this one says your population has a mean of 48, a standard deviation of 9. It's going to let you use the central limit theorem. Okay, wants the probability, tells you your sample size is 25. Okay, now I know that's less than the magic number of 30, but let's just go with it. I didn't make up the study guide. Okay, so this wants us to find the probability that the population will be more than 53.35. Okay, so we need a lower bound and an upper bound. We want to be more than 53.35. So our lower bound is 53.35. And our upper bound is infinity. Our mean, it's 48. Remember, the mean does not change. We saw that up here. Whatever the mean of the population is, it's the mean of the sample. But they gave us a sample size. So we can't plug in 9 for our standard deviation. We're going to have to calculate it. It's going to be 9 divided by the square root of 25. And I came up with 1.8 for that. So when I plug all of that into normal CDF, I came up with 0.0015. Okay. Does that sound okay? Anybody have any issues with it? Okay, so again, I know I keep saying the same thing over and over again, but I just get so many students that get confused. I want to make sure you realize if it gives you an n, you just take the square root and divide your standard deviation. Otherwise, it's just like chapter 6. They're all kind of the same. All right, let's do the last few then. Okay, last page. Okay, so 33, the time spent commuting from home to work for all employees, I feel a population coming on, of a very large company has a normal distribution with a mean of 42 and a standard deviation of 12 minutes. Okay, the probability, okay, we're using normal CDF, that the mean time spent commuting from home to work by a sample of 16, okay, that means we have to find sigma x bar. Employees of this company will be between these two boundaries. So we have a lower bound of 46.26, an upper bound of 49.35. We have a mean of 42. We're going to plug that into normal CDF, but we do need to find sigma x bar. So we're going to have 12 divided by the square root of 16, which will be 3. And I think it's 0.0707. Okay, so normal CDF, lower bound, upper bound, mean, but we use this sigma x bar because we had a sample size. Say that again.
If they give us a standard, if they give us a standard size, we don't use a standard deviation.
Exactly. If they give you a sample size, do not use that standard deviation. Use it in the formula to find. Good. Okay. Sound good? Okay. All right. Now, okay, 34 and 35. So that's really it for that kind of portion of the test. Is everybody okay with those? Okay, let's look at 34 and 35. They're basically the same. So let's just read 34. A company that provides financial services prides itself on the percentage of college graduates it employs. It has 500 employees. That's the population. 200 of them are college graduates. That's the characteristic of the population that they're talking about, okay? It wants the proportion of all employees who are college graduates. All right, so what it's wanting is back on your key formula sheet, it wants this situation up here, this little X over N. I mean, you really probably don't even need that formula. You would probably do it anyway on your own. But what it wants to know is what's the proportion who are college graduates? Well, 200 are out of 500 total. That's all you got to do. That's what they're looking for. And that answer is D. Okay, now let me warn you. Some versions of the test have question 34. You guys are going to do great on it. Some versions of the test have question 35. The only difference in 34 and 35 is this little word was added in 35. The little word added is how many are not college graduates. So let's think about this here. 500 is the population. If we want to know how many are not college graduates, there's a couple of different ways you could do this, but 200 of them are. So how many are not? 300. That's the number you want to use, and they didn't give it to you. And that answer is going to be 0.6. Now, another way you could have done it is you could have left the 200 on top and realized 0.4 are, and then what you know about probability is that it has to be added up to 1. So if 0.4 are, how many aren't? 0.6, right? You could have just subtracted. So you can get there a lot of different ways, but you're going to have to really, I don't know why they do this. It's like, if we're going to just trick, let's just have a class of tricks. But if we're going to test on statistics, let's test on statistics. So anyway, be really careful with 34 and 35. I don't know which one you're going to get tomorrow, depending on which test version you get. So just be really aware. You're going to only have one, but I don't know which one it'll be. Okay. All right. Last but not least, I see percents. So now we're going to talk about proportions or percents. Okay, we're still going to use normal CDF. That doesn't change because we're finding probabilities, right? So we're still going to use normal CDF, but here's the situation. Lower bound and upper bound, no big deal. When it comes time for your mean, go to your key formula sheet. The mean for these P's, look, it's P. That's your mean, is P. And P is going to be that first little percent that you get. It's the little fun fact percent. You're going to have to turn it into a decimal. But that's going to be your mean, okay? Then it's going to want the standard deviation. But what we're going to do, because they give you a sample, remember, anytime they give you n, you can't use the standard deviation they give you, not that they give you one here. To find your standard deviation, you're going to use the square root of P times Q over N. That's also on your key formula sheet. It's right here, okay? On your key formula sheet if you need it. Now, what's not on your key formula sheet is Q. How do you find Q? Good, subtract P from 1 minus P. Okay, so that's not on there. You're going to want to make sure you know that. All right, well, here we go. Let's jump right in. So 36, 20% of all persons prefer strawberry to chocolate ice cream. These are not my people. Okay, so 20 is spelled out in a word. All right, there's only 9 of you and you guys are super smart. But when I have really big classes, I can very easily tell you 5 of you are going to tell me there's no P given because you don't read words, you're just looking for numbers. So my P, the first little fun fact given, is 0.20. That's going to be my mean, okay, right there. The probability that more than 18% of all persons in a sample of 1,000 will choose strawberry over chocolate ice cream. Okay, so here we go. Let's do our normal CDF for 36. Okay, I need a lower bound and I need an upper bound. Okay, so more than 18%. So 18% and more. Now we can't put in 18, right? My lower bound is going to be 0.18. My upper bound is going to be infinity, right? It's not going to be 1,000. It's not going to be any other. It's going to be infinity. Those have to be your bounds, okay? Your mean is going to be what for that problem? 0.20, right? That was your P. Your P is your mean. And then your standard deviation, because they gave you an N, you have to calculate. So it's going to be the square root of 0.20. What's my Q? 0.8 divided by 1,000. Okay. And what did I get? I come up with 0.0126. And when I did that, I came up with 0.9441. Okay. All right. Does that sound okay? That's the toughest one. If students are going to get stumped, it's usually these last two. All right, let's look at number 37. Okay, again, they wrote out the word. 10% of all persons are allergic to penicillin. That's your P. Also your mean. Remember your first little percent, your little fun fact where they talk about a population, that's your P or your mean. This wants the probability that less than 7% of persons in a sample of 1,000 will be allergic. Okay, this would be a great one to try in your calculator because something wonky is about to happen. So this, and it's going to happen on the test to you. So let's try this together. All right, we want, okay, our lower bound. Well, this is less than 7%. Okay, first of all, what is 7% as a decimal? 0.07, right? I promise you somebody in here is going to put 0.7 in their calculator. It'll happen on the test too, okay? So remember to divide by 100. So if I want less than, my lower bound is negative infinity. My upper bound is 0.07. Don't forget that. It's 2 decimal places. Okay, my mean is going to be 0.10 because that's my P. And then I'm going to have to calculate the standard deviation. So it's going to be 0.10 times 0.90. Remember, that's Q. I just did 1 minus P all over 1,000. And what did I come up with? I came up with, I think it's 0.0095. Okay. All right. So then when I go to put it in my calculator, and I know my little movie people can't see this, but I'm going to describe it for you. So if I put this in my calculator, normal, wait a minute, normal CDF. Okay. -1, 0.07, 0.10, 0.0095. Okay, so you can't see this at home, but what just popped up on my calculator is 7.9463 e to the -4. Okay, so remember, we talked about this before. This is your calculator's way of saying 7.9463 times 10. Oh, you can't see me up there. Times 10 to the -4. This is your calculator's way of putting it in scientific notation. What you got? Did you? What'd you get, Maddie?
I thought negative 0.996. I did it wrong.
I don't know what you did. Let me see what you put in. Oh, what'd you round it to?
I just copied and pasted.
Oh, okay, what was your, that should be fine. What was your lower bound? Okay, that got it. Okay. All right. So when you get this in your calculator, what it really means is scientific notation. Remember that? That's all that means. So what this means is, here's your decimal point. We want to move 4 places to the left. So 1, 2, 3, 4. And then we want to fill in those places with zeros. Okay, there we go. There's our answer. And then when I'm looking on my answer choices, they're rounded to 4 decimal places. So then if I round this to 4 decimal places, the 9 is going to make the 7 do what? Go up to an 8. And then your answer is B. So again, it's just full of these little sneaky things that drive me up the wall. So make sure it's the very last problem of the test. So finish strong. Make sure when you get this wonkiness, write it as scientific notation, scooch it over, round it, and then you should have your answer. And then don't forget, if you want to either take a screenshot, or grab a chapter 6 packet. I put a ton of them back there. This is in there. This would be your bonus. Okay. And then that's it. So I can't believe it. Bus was late and somehow we managed to get it done.